In this video, we're going to be looking at the laws of sines. We use the law of sines when we have an oblique triangle, which is just simply a triangle that's not a right triangle. This is basically the equation for the law of sines. So you take your side A and divide it by the sine of angle A, and that's going to be equal to the side of B divided by the sine of angle B, which is equal to the side of C divided by the sine of angle C. You can write it like this, or you can flip them all over and put the sines on top with the sides in the denominator as well. Here's how you would use the law of sines if you're given this triangle here, and we wanted to finish plugging in all the sides. We can use the interior angle rules to find angle B first, which gives you 60.9 degrees. Now for the rest of the sides, we can use the law of sines, like so. So we have 21.6, which is side A, divided by the sine of A of 102.4, and that's going to equal side of B divided by the sine of angle B, which was 60.9, and we just simply simplify that, giving you 19.3. And then we want to find the side of B, the side of C, which means we got to do it again using either A or B now. So we can use A again. 21.6 divided by the sine of 102.4 is going to equal C divided by the sine of 16.7. Simplifying that out simplifying it like so gives you 6.36. Now we've solved the entire triangle. Now this works in most cases, but there's a special situation with the law of sines, and we call it the ambiguous case. And so we're going to look at this triangle, and we have angle A is an acute angle, all right? And then we take that angle, we can draw up a height here, and you see that the height is equal to B times the sine of A, which should make sense based on what we know about sine. So if we take side A and set it equal to H, we can make one triangle. All right? If the side of A is going to be less than H, like so, you can't make a triangle like that. But if the side A is greater than B, then you can get a triangle. Now here's where it gets confusing, because if the side A is in between the length of H and B, then you can actually create two triangles. And if you remember, going back to geometry, you did the hinge theorem, which, given two sides and one angle, two different triangles can be made. And here's a simple example of that hinge theorem, where you can have your angle of 42, side of 15 and 11, and create two different triangles which clearly look different. All right, and so when you're dealing with the law of sines, you have to take this into account. Now if you're dealing with an obtuse angle, where angle A is that obtuse angle. If A is going to be less than or equal to side B, you will not create a triangle. If A is greater than B, then you get one triangle. We can also use two sides and an angle to determine the area of a triangle as well. So you're used to seeing area equals half the base times the height. Well, here, these are their formulas for the area using a sine of an angle. So let's go check out a couple examples. If we wanted to find the missing angles and sides, you got an angle of 36 for angle A. You got a side of 8 for side A, and then B. The side B is equal to 5. So we know that if we use the law of sines, we can calculate angle B like we do here, and then using the laws of triangles with all interior angles equaling 180 degrees, you can just subtract and get angle C, and then to find the last side, side C, use the law of sines again, and you end up at side C here. And that concludes this slideshow.